In a previous video, I built an eFoil using a really small kite foil that I picked up off AliExpress. It worked okay, but it's definitely not ideal. The problem with foils is they're expensive, and to really make the most of your time out on the water, you need multiple wings. Plus, I'm still learning, so I have no idea how, say, something like this, an high aspect wing, compares to a lower aspect wing. Now I thought, why not try making my own wings and compare? At first, I tried carving one out of wood, like this here, but it just wasn't accurate enough. So enter 3D printing, because let's be honest, it's a solution looking for a problem. Now, I also have a replica Access PNG 1310 foil designed for pump foiling, and I've been using it on the eFoil too. The cool thing about it is I can get up on foil at insanely low speeds. The downside is it gives so much lift that I can't go fast, which makes it hard to stand and like really carve, especially sharp turns. So making a few different foils to test without, spending a fortune would be awesome. So let's jump into OnShape, where I modeled a few wings. I'll share links to the wings so you can tweak them yourself. Just go easy on me, my CAD skills aren't perfect, but hey, they get the job done. I designed a bunch of different front wings, a replica of an Axis 1150 PNG, and a few low to medium aspect wings. The beauty of CAD is that it's easy to tweak the size and thickness by changing a few parameters. For printing, I use PLA with 10% adaptive cubic infill on my Bambu Lab H2D. This printer, by the way, is sweet. It's been running non-stop since I got it, and the prints come out perfect. I thought the X1C was like a plug-and-play printer, but this takes it to a whole other level. Bambu provided me this printer to use in my projects, and the large build volume is exactly what I need for these wings. I've also printed a couple of folding propellers on it, and the heated chamber is a game changer for exotic materials like carbon fiber nylon and polycarbonate. The blades have been performing great, and it's nice to know if I damage one, I can just print out a replacement or keep a few spares on hand. If you need a 3D printer, definitely go check them out. Their printers, they just work. Now, if they would just make a Delta printer, that would be perfect for printing these foils in just 2 halves. All the strength for these foils will come from the fiberglass and the epoxy. But the mounting point where the foil meets the fuselage, I used a modifier to make that area 100% infill for extra durability, as it will be compressed with the screws against the fuselage. I've test printed a few different wings, and eventually I'll try them all out, but in this video I'm focusing on 2. The Axis PNG 1150 replica, which is not really a high aspect wing by today's standards, and a medium aspect wing based on the Axis BSC 1120. And I printed this out on the H2D because it's definitely tall, doesn't fit in the P1S or the X1C obviously, but no problem in the H2D. I just love how quick this printer lays down filament. I suppose no different than the other Bambu printers, but it never gets old watching it. The spaghetti detection worked. It stopped the print. It tipped over. Whoopsie. I can just reprint this. I can measure and just reprint the little bit that's left over. I'm going to use Weld-On 16 to glue the wings together. And then I left 3 large holes here where the bolt holes will go. I'm going to reinforce this area here with lots of glass. This area here is what takes on like the most amount of stress because it's where it attaches to the fuselage. After building up the fiberglass in the 3 spots for the screw holes, I sanded it down so it's nice and flush. That way I'm going to apply glass over the whole thing. I'm going to round these edges so the glass drapes nice over it. And now I just need to glue on the wingtips, and then it'll be time for glassing. Since this is hard to clamp, I'm just going to use some Gorilla Tape, because these are printed really lightly. 10% infill with 2 layers, 2 perimeters. They're very light, so the glass is where it's going to give it the strength. All right, what I'm going to do, round this edge off because it makes glassing a little bit easier. I should have maybe modeled that into the 3D model. I'm going to glass this part really strong here in the center, and then I will glass the wings up to it. Okay, I'm just roughing up the wing, just so that the epoxy just has more to grab onto. Giving this a wipe down with some acetone. I made a modification for how I've been modeling hydrofoils for the mounting. This one here is raised for where it mounts, whereas here it's recessed. This is an old way I was doing it. This is the new way because I realized that glassing, it is a lot easier having these nice rounded corners. So keep that in mind if you're designing your own, that the mounting is very important, because glassing that area is quite difficult if you have a lot of sharp angles or if it's recessed like this wing over here. This is definitely stronger as well because you don't have sharp angles where if you get stress, it'll be more likely to crack there. What I'm going to do is repeat and just add a few more layers in the center because this is where a lot of the stress is. Not to say that the wingtips don't get stress, but this part here where it mounts, I want to be in particularly strong where it mounts to the fuselage of the foil. And then I'm going to put 2 layers of 6-ounce cloth over all the wings. Now that those center sections have cured, I'm going to add a little bit more reinforcement. I'm going to wipe it down with some acetone and then put a layer of glass on it. And since I have a whole roll of e-glass, 6-ounce e-glass, that's what I'm going to glass my wings with. If I should decide to make lighter and stronger ones, I'll get carbon fiber. Alright, I'm going to put 2 layers on the top. Alrighty, got the wing all laminated. And check this out, I even printed off a label for it with the specs. Next up, I'm going to put a hot coat on this, sand it smooth. I also got a new mast for my foil. This was way too short. Look at the length of this guy. Now that I've gotten used to riding, I've actually been riding my axis foil on my eFoil, but this one here was for my cheap AliExpress foil. I got a longer mast. This is 90 centimeters. I totally noticed when I'm out in the swell that you really need a longer mast, definitely. So I'd recommend, if you can, initially start off with a longer mast if you can only afford to get one. I had taped the trailing edge, and I also put a tape on the leading edge here, so that way any drips, you don't have to worry about sanding them off when they're on the bottom, because it makes a real mess. That's a tip for those of you who don't make surfboards. That saves a lot of labor and headaches. And then what I do is I tape right below my tape line from last time, which I don't think I showed you. Anyways, this is what I'm doing. I'm just putting it just below where the last tape line was. This just makes sanding a lot easier later. Not that there's going to be a ton of sanding. And of course, since I've been touching the foil that's been laminated with my bare hands, which have all kinds of like oils and just greases or waxes, could be all kinds of stuff, contaminants on it, I give the wing a wipe down with acetone. My epoxy of choice is Greenlight Surf Supply marine grade epoxy resin. This stuff has UV inhibitors in it, although just about every epoxy will turn yellow over time. But I like using a scale to measure out my epoxy. I'm going to do 35 grams probably or so. Mix really well, scraping down the sides. I'm going to use my bristle brush to put on the hot coat. I didn't mention it before. Now, not all of you build surfboards, but this is very similar to how you would do a gloss or a hot coat on a surfboard. You use your brush and you plow the resin along. The strength really comes from the fiberglass. The smoother you get it, the less sanding. And as you can see, no fish eyes whatsoever. That's always a bit of a worry at first, and that should do it. Let this set up. I'm going to give it a sand and we can test out this foil. Now I'm going to wet sand this. I'm probably just going to start off 400. I don't really need to give this a showroom finish. I just want this to work, but I want it to be nice and smooth, and the finish actually came out really smooth anyway. There's a little bit of a mean blush on it, so sandpaper will take that off. It's a little humid when I put the hot coat on. Nice solid connection. That's looking awesome. Not too bad at all. Quite pleased with this. And just for comparison, I actually have an Axis 1150 PNG. When I originally modeled this, I didn't have this, and I just used what I found online for a picture and then modeled it after that, and I'm happy to say that they match up really well. Now the profile is just a little bit different, but the outline and shape totally matches. The only difference is right here, just at the end and the trailing edge. Mine's just a tad bit wider, but the rest of the profile is like perfect. Next, let's hit the water. The maiden voyage of the 3D printed foil.
Is this fancy looking one here?
Like every good project is held together with duct tape. And I also have a 3D printed propeller blade. So this is all printed on the Bambu lab printer that they graciously provided me. I was not going to turn down a free printer from them. This is also an old surfboard that I repurposed.
That looks like a fancy screwdriver.
Dollar store.
Is it?
And a little more duct tape. Works. I'm gonna go get changed.
Oh, up and away. Oops, kerplunk.
Today's setup is a little different from my usual eFoil rides. I decided to test a 90cm mast for the first time and paired it with an old surfboard that had way too much tail rocker. Bad idea. It was like super unstable, but hey, you never know until you try. 90cm is too tall for my skill level, and as an old surfboard, yeah, it's not an ideal eFoil platform. Also, the AliExpress foil is not exactly the stiffest foil either, so that probably played a little bit of a role. The good news, the 1150 replica wing has got tons of lift, and I'm popping up on foil at around 12 kilometers an hour, which is pretty low.
I might go over and attack these. Oh, he's doing really well. Oh, kerplunk. Let's see.
Starting to get the hang of it at the end.
Yeah, you're looking really good.
It's really tippy because it's such a tiny board. Alright, I'm trying a smaller mast today, a little lower. It should be a little easier to use. The 90cm was just a little too tippy. I swapped to a 60cm mast and tried the replica 1150 PNG and the 1120 BSC front wings in the lake. For me, a 75cm mast seems to be the sweet spot, but unfortunately, I don't have one for this AliExpress foil, only for my Axis setup. Here, I'm having a great session and able to turn and carve a bit, but I am breaching the motor a bunch. This is riding the 1150 wing and it's got so much lift, but paired with a shorter mast and more stable board, I'm having no issue staying on foil. Really nice to be able to just swap them out. You can kind of see here the aspect ratio. There's like an extra about 1.25 inches wider than the replica 1150. All right, we've changed out the wing. We're going low aspect. The 1120 wing is a much lower aspect wing and it turns super easy, and it's also way more forgiving than the 1150. If I turn and want to turn the opposite way, it's super easy to pivot, but it doesn't feel unstable. But it definitely doesn't glide as well as the 1150. It was all going great until I noticed I started falling a lot with the 1120 wing. What I didn't realize at the time is the mounting area around the fuselage for the wing cracked. You can see I'm super wobbly here. And as I mentioned earlier, when I was glassing the wing and designing it, I knew this could be a problem, and that's why I designed the 1150 wing differently. I just didn't think it would break this quickly. Making those wings with areas where there's stress risers, right here. Look at this. Got an issue right here. It's already cracked, and it's cracked right in along the edge here, which I knew was a weakness. That design over there, way better. But this one, now this wing already is filled with water. It is so heavy, but look at the water coming out of it. I was wondering why my foil was getting all really squirrely out there. I was like, is it me or the wind pickup? But no, it's totally, this started getting really loose. And I was still able to ride it in. But, okay, we know what not to do. We're gonna stick with this design here, stronger. So when not broken, the 1120 lower aspect wing is good for someone learning, or if you want a more stable, forgiving ride. Here I switch back to my converted prone foil board from my DIY eFoil build and headed into some open ocean wind swell. Same 90 centimeter mast, but this time way more stable. And wow, this foil, it's got so much lift that even the tiniest bumps were easy to catch. Honestly, with power assist, I could probably run a smaller foil. This isn't a true foil drive assist, so the motor is in the water and it adds a ton of drag when I don't have power going to it. And the whole setup is, well, super heavy. Still, it was a blast cruising around and chasing waves. Now I'm motivated to build the real thing, a proper foil assist prone surfing board that's super light with all the electronics fully integrated. No more makeshift waterproof boxes, but that's for another video. So overall, is 3D printing wings viable? Absolutely. I think this is an inexpensive and fun way to learn about how different types of hydrofoils work. I'm also going to make some rear wings too, which should be a little bit less labor intensive. Well, I hope you enjoyed this video, and I'll see you guys in the next one.